Welcome back, everybody. We are up to Unit 4, Lesson 15. There are no new lesson notes for this lesson, so let's get right into the examples. A population of cicadas is modeled by a function defined by f of w equals 250 times e to the 0.5 times w. This is that alternative exponential growth formula that uses e, where W is the number of weeks since the population was first measured. Explain why solving the equation 500 equals e to the 250 e to the power of 0.5 W gives the number of weeks it takes for the cicada population to double. Well, according to my function here, what is my initial? My initial population is 250. And what is double 250? 500. And what did they set the equation equal to? 500. So explain why solving that equation gives the number of weeks it takes for the cicada population to double, because 500 is double the initial population of 250. Okay? How many weeks does it take the cicada population to double? Show your reasoning. So we are just going to go ahead and solve this equation right here. So I'm going to switch around the order and make it 250 times e to the power of 0.5 w equals 500. Okay. So I have to isolate the exponential term, remember. So in order to do that, I need to get rid of the 250. So to do that, I'm going to divide both sides by 250. So that gives me e to the power of 0.5 w equals 500 divided by 250 is going to be 2. Okay. I'm now going to write this in log form. So this will be log base e of 2 equals 0.5 w. And then I'll switch around the order again. So 0.5 w equals log base e of 2. So I'll finish it off by dividing by 0.5. So w equals log base e of 2 divided by 0.5. Okay, so that's one way we could write the solution. Or remember, when it's log base e, we could write it as natural log. Natural log precisely means log base e. So I could write it as ln, or natural log of 2 divided by 0.5. Either one works. So that's number 2. Number 3, use graphing technology to graph y equals f of w and y equals 100,000 on the same axes. So let me go to Desmos. So when I do this, I'm going to have to replace, when I do this, if I type in w, it won't graph. So I'm going to replace the w with an x. So the good thing about Desmos is if I type in e, it will interpret it as the number e, not the variable e. So 250 e to the power of 0.5. Instead of using w, I'm going to use x. And then it also said to graph y equals 100,000. So obviously we have to zoom out quite a bit here. Okay, so there's my graph here. So there's the graph. So the question says, explain why we can use the intersection of the two graphs to estimate when the cicada population will reach 100,000. So the intersection of these two graphs is going to be the point at which the population is 100,000. Okay. And it's going to be almost 12 weeks later. So the point, the x value of that point tells me the number of weeks until it reaches a population of 100,000. So for number 3, I am going to write, because the x value of the intersection point gives us the number of weeks until the population reaches 100,000. Okay. And as we said, based on the graph here, it's a little less than 12 weeks later. Okay. So that is it for the examples, and that is it for this lesson.